Today's topic is what's new, SOLIDWORKS 2011, in the area of sketching, features, parts, and surfacing. So hopefully I can fit that all in, but there's only a few in those sections for each one of those. So sounds like a lot, but we should be able to fit it in. So without further ado, let's get into some of the what's new sketching stuff. One of the big things, or the only big thing in sketching, and there's always user interface things that apply to every area of SOLIDWORKS, and we covered that most of those in the last webcast, which is archived already on our website, is sketching. And this new tool called Grid System. Let's go ahead and take a look at that. So I've just got a empty part here open, and it's not any kind of sketch that you put in. You actually have to go to Tools, Insert, Reference Geometry, or if you have a shortcut toolbar button, you can get to it. Insert, Reference Geometry, Grid System. And when you click that, you'll notice that I'm kind of like in a sketch mode already. So I had a brand new part, nothing was open. Now I'm in sketch mode, and it's actually got kind of this weird 3D grid icon next to it. But basically, it's just asking you to start drawing your grid, and I'll kind of just, make a shape there. Let's just put a couple dimensions. My part's in meters there. You'll notice these balloons start popping up, the 0 and the 1. I'm just going to go 4 meters by 5 meters, maybe. And you can see it's putting these balloons in, and I'll just, you can adjust these things in here. Let's put a few more things in, just a linear step. Let's do a meter apart. Add a couple of those. And basically what you're doing is you're kind of just drawing the wireframe grid here. And maybe we go to this one. And let's just do this. Again, I'll make this my last one just so you can kind of get the point. Obviously, you can put a bunch of dimensions in there. You'll also notice it's putting these sort of balloons in. It's updating those even though I drew them in a different order. This was the last line I drew. It did update this to be. You got kind of your quadrants in this grid system. When I'm done with my sketch and I'm happy with everything, I can just exit the sketch or hit OK here. And it takes me to the next step of the grid system, which is to specify the number of levels of this grid. So you can see how many number of levels. So I have 3 spaced at 2 millimeters apart. I can add more. So the first one is the 0 height, second one, and so on. And I can change the height in between if I want one of these, if I'm making, like, let's say some kind of rack or some kind of shelf, and the first shelf is 2 meters, the second shelf is 3, the next one's 2, and then it's 3 again. I can, so on. I can do that however I want. There's also some options here for the auto number balloons, which is already turned on anyway. If we added more stuff to it, we can change that. And then I get kind of this grid. And what this can be useful for is building, any kind of any sort of repeated pattern of shelving or any kind of rack or any kind of stuff that you might come up with. It puts this grid system feature, and it actually, you can see it's got these derived sketches from each one. Behind the scenes, it's got this 3D sketch. The best way to view this stuff, because I know you're going to be working and editing this, is they actually have, if you right-click, you can choose View Grid Components, and it'll give you a little sort of pop-up menu here that you can keep wherever you want on the screen. So I might put it here. My surface bodies, it works just like the feature tree. It just makes it a little easier to see everything, especially if you got a lot of stuff in the tree already. You can just look at the grid component. You can see when I turn these all on, it turns all these on also. And what are these things? It actually created surface bodies in there for each one of these items. So basically it took this line and extruded a surface up to it. So if you want to build some kind of surface pattern, you can thicken those, you can do whatever kind of surfacing you want on those. I'll go ahead and hide them. The other thing it did is it's got planes in there, as you can see, sketch planes, and these are 2D sketch planes, right? It's also got I'm sorry, they're regular sketch planes. It's got a 3D sketch here. I'll show that so you can see it drew the lines between each one, connecting all the endpoints together. And this line right now, you can see it's one continuous line. That was the one option I didn't check in there. So if I go back to edit my feature, 3D sketch split lines, I can actually have those 3D sketch lines that it puts in there. and have them split. So if I click OK, now you'll see when I highlight it, it only highlights that segment. It actually split the lines into separate lines. So those are some of the options. Now, once you can play with this all you want. You can hide the different sketches. You can do whatever. You can go back and edit it and add more layers to it. Let's say let's use this for something. Let's come in and do a structural member, just so we can see everything. I'm going to close that box, and I'll just accept the whatever I last used there. Size, excuse me, size-wise, maybe that's the biggest one I got on there. Yeah, and put in some stuff in there. Add a new group. Let's put in one here, maybe one here, and drop one in here. So you could see I could continue, add more and more structural members to this as I go. They don't have to be the same thing. I'm not using all the lines on every level. In one level I use one, and the other I don't. Once I'm happy, again, just like you use weldments, you can see now I have a structure in here. So very useful tool to if you're doing stuff like this, if you're doing these grid kind of things where you have quadrants, where you have areas that you need to know, it'll put all this stuff in there. All right. And let's jump over to the next topic here, which is features. Again, looks like not a lot, but some very powerful functionality that wasn't there before, or some nice enhancements in the Helix. Let's jump into SolidWorks and take a look at that. Let's see here. Bear with me, I got to remember where I put my stuff. Helix, okay. So I've got a part here, and you may have seen this sample if you came to one of our rollouts, but basically, it already has the Helix done, because the Helix isn't new. What is new is some of the functionality of it. So I'll go ahead and edit the Helix, and we'll take a look. Right away, you get these callouts. Right now, you can see I'm doing a pitch and revolution variable pitch option, where you put in that stuff. You see how some of the columns are in gray here in the property manager. Those are reference columns. They're not, those aren't the ones you're editing, because we're in pitch and revolution. So pitch and revolution are the only things that I edit. Basically, I can edit them over here too. You could see the same for height is not an editable column. So it's basically got a 0, it's grayed out, but I can go ahead and I can type in these just like I would over here on the left. So these callouts are improved. When it's a constant pitch, you also get the callouts now as well. The other thing that you can do is you can specify height and revolution as variable pitch now too. Previously, only pitch and revolution and height and pitch were available for variable pitch. And you can use height and revolution when defining a constant pitch now as well. So when I switch over to constant pitch, you see I also have height and revolution in there as well. The nice thing about this too is it doesn't, this seems kind of obvious here, but if I change to one of these other ones, you'll notice that the height, I'll switch to height and revolution. Height's going to jump over here, pitch will be over here, but it doesn't change any of the numbers when it moves the columns around. So I'm not losing any definition in there. So if I know some of these things by height and revolution, I can assign those, and then I can switch over to pitch and revolution and assign those as well. And it doesn't lose any of that information. It converts it over to whatever it needs. So having these reference columns makes it really nice in here. So some cool stuff to the Helix command, just to make definitions of it, and doing stuff like this part here you can see a little bit easier to define. And revolve. Now this is a small one, but pretty powerful tool. You can now do up to vertex, up to surface, and offset from surface. And let's jump into SolidWorks again here and take a look at this. And let's see, revolving. So just like an end condition on an extrude, you get all those options. And I kind of know this is a pretty simple part here. I'm going to go ahead and revolve this sketch here in there, and we'll kind of look at it like from a little bit different angle. And again, this could be a revolve cut, it could be a surface revolve, or a revolve base in this case. They all basically assign it. Obviously, there's some different options in there. And let's say, I didn't want to go there. This is going to be some type of handle or something I might put on here, or a guide or something I want to put on the top of this. So I will go, let's say I'm just going to go 85 in one direction. Well, that's not quite right. I'll kind of back this up to a certain amount. You've always had this problem where you're looking at it like this. If the part isn't thick enough and you need to stop it into the part, and then what happens if the part dimensions change and now it's not touching or something like that. So what we do is we'd move it advance, and then we take this face and cut away anything that wasn't there. As you can see by when I selected that face, I have this up to surface now option, and it doesn't matter which face in this case isn't going to change. But I have that for direction 1 and direction 2, and there's up to vertex. So if I want to click like a vertex now, I can do that as well. So just having different end conditions really saves you a couple extra steps here of cutting that end off, or cutting that little part off, or just figuring out another way to revolve, start the revolve from here and then go up or something. So you have a lot more freedom. Let's look at direction 2, and I'll use offset from surface on this one. And of course, let's offset it enough so that you can see it. So now I have an offset and an up to surface. I'll click OK, and I always like to clean things up a little bit here. We'll just put a fillet on that face just to kind of make sure we don't cut our hands on the guide or something. So really small, simple example of where this is useful, but being able to revolve up to surface, up to vertex in different end conditions on there is a nice enhancement. And as I mentioned, this works for cuts, go back, cuts and surfaces revolves as well. Let's look at this last one here, scale. Actually, not much to show in the scale, and keep in mind, by the way, if you have any questions, feel free to type them in as we go, and I'll try and answer them. But the only thing that you can do is you can adjust the scale by configuration now. So it's configuration specific. If you use a design table, I put the syntax in there. So for example, I can do a quick example here. If I jump into a new part, just draw and extrude on here. So insert features, scale. The X, Y, and Z are now configurable. Notice when I put this in the first time though, there is no configuration. This is the only dialog box in there. So let's say I want to scale this thing, up 10% or something like that in all directions, or maybe I want this direction to be 20%. I click OK. Well, now when I go back and edit it, actually, I don't have two configurations, do I? Let's just add another config. When I go back and edit this thing now, I do have the option for different configurations in there. So the problem is you can't really, while you're adding this, you can't specify configuration. So while you're inserting the scale feature, because the feature doesn't really technically exist until you hit OK, once it exists, now you can configure it. So you kind of have to go back in this dialog box, or if you're using a design table, there's that syntax for the scale feature for each dimensions, and I'll go back to that. So now you can configure the scale feature basically. And I put this note here, if you're using a uniform scale and you want to use it in a design table, you only need to do the x-axis. That's the one that has all three directions if you're doing uniform scale. Alright, that's the feature stuff. Let's take a look at parts. Alright, the D-feature tool. I'm going to show you the beginning of the D-feature tool, and you'll have to view the couple of webcasts from now, the assemblies what's new, to see the full extent of it. But it works in parts also, and what it is basically a tool to de-feature a part. I want to say simplify a part. A lot of reasons you might do that. One, just for performance inside of SOLIDWORKS. Maybe you want to have a version of this gasket or something or part or some kind of complex thing that doesn't have a lot of It doesn't have a lot of detail to it. Another would be for privacy or IP type concerns where you're worried about someone seeing something they shouldn't see. For example, here's kind of a small example of a part, but this is my gasket or some kind of spacer or something like that I might be using. But basically, I don't need all this data. When I send it out to someone else, I want them to have some of the data, but not all of it. This is maybe proprietary information or some kind of stuff I want to really keep secret. Or maybe, again, I got to use this 1,000 times in an assembly, and I'm worried about all this extra detail is just going to bog it down. This isn't the greatest example. It's not that complex of a part. But so, tools, defeature. And again, this works in assemblies, and there's some added benefits because you can actually remove parts and stuff as well. But I'm only talking about parts today. And you can see the tool tips here at the top. Pick the features you want to keep. So maybe, these holes, and it's actually, I could do it by face. I can click off the tree and get, I did this as one hole feature. Do I want these holes? You'll notice there are also some tools to help you auto-select stuff. There's even a section view tool that basically turns on that section view that you can turn on anyway, but just to help you select stuff. So if you're working in an assembly, it's kind of nice to have, section it, grab the parts or faces you need, and just to be able to see things. I can say select all holes. You see it finds any holes in there. Select holes between a certain amount in there. I'm just going to go ahead and pick some stuff off of there. I'm going to pick that and maybe this one hole here or something like that. These are the only critical things that I need to pass on to someone else. I hit next, and it tries to sort of do this. Okay, I'm going to take those two things and do something with it and put them side by side here. So you can see, this is what it looks like. This is what the other one looks like. You'll notice it had to keep a lot of the detail in there. Let's say, hey, look, it didn't grab. This is SOLIDWORKS. I'll back up one step. Let's take that face out. Hit next. So fully editable, and it says, okay, SOLIDWORKS is, the code, the programmer, the kernel, whatever, is saying this is what we think you need in there. However, it's saying, hey, if you see something that wasn't automatically selected, go ahead and pick it. Again, and I have some options to section if I need it. So maybe I pick this and say, I want this entire feature. This doesn't need to be in there either. Even as far as these cuts around the outside or something like that, maybe just this face or something can be removed, this feature, or a body if I had a multi-body part. Let's just go ahead and stick with this right here, this center cut that I put in there, which also includes a fillet. Notice when I clicked feature, it knew a child feature was part of it, this fillet. And then, so I can hit next. So the steps are, you pick what's critical, you pick what's, and then you hit next. It tries to defeature it. If you find that it's not defeaturing it enough, you can pick more stuff in there in step 2. And then the final step here is what do you want to do now that you've chosen this stuff. So now you can see this is what the finished product on the right is going to look like. This is the start part. I could save the model as a separate file. If I click this and I hit OK, it's going to prompt me to save it. I could publish it to 3D Content Central, which if you've ever used that, has a lot of vendor parts and store-bought parts, manufactured parts on there, and then also a lot of user content as well. Or I can just store it in this thing in case I want to come back to the defeature tool and adjust this later. I can do that. Now the one question I've gotten so far is, why not just store it as a configuration? Why is there not an option to add this as a configuration, a defeatured or simplified configuration? Because and the best, I guess, answer I can give you for that is that's not what defeature is really for. Defeature is for to simplify your model for publishing or privacy type things. And I said in the beginning, maybe you want to simplify it because you want to insert it into an assembly a bunch of times and you're worried about performance. You can use defeature for that. It's definitely a use of this tool, but that's not really what it was intended for. That's more of a, you may want a simplified configuration instead. And in that case, you want to use, some type of simplified tools to clean up your model. So this is for, the reason SOLIDWORKS put this in is to defeature large assemblies and complex assemblies. Maybe you have some type of motor where you don't want everybody to know all the cool stuff you do inside the casing of the motor, but you need to send that motor out so people can build their other parts around it, or they can order it from you online or whatever. This way, the inside is just a block. It's blank inside. It also will maintain mates and stuff like that in assembly. And we'll go into this further when we do our what's new assembly stuff. But really, I can save this as a separate file right now. I click OK. It prompts me where do I want to save it. And this is the one that I can say OK to send to vendors or something. Now they don't get all that proprietary information that I don't need them. They have exactly only what they need to do. And again, you can see it's renamed it if you can see the title block here in this part. So that's the defeature tool for parts. Now the same tool works on the assembly level as I mentioned. So stick around or join us for that webcast, or if you're watching this in an archive, you may want to download that one as well. Okay, where are we here? Okay, so now we get into some really cool stuff that you can do with parts and equations. You can now import, export equations, and you can do the Visual Basic IIF function, so an if-then kind of function. I'm not a programmer, but I know a little bit of the logic stuff from 100 years ago when I was in school. So anyway, I'll show you some of that stuff. Basically, all you can do with that function is the suppress and unsuppress. But I've got kind of a very simplified scenario here from the tutorial stuff that'll explain this a little better here. So let's just open up that example. So this is a very, I'm calling this the front plate. This is a very, simple part. It's got a linear pattern of this hole. You can see just, you probably already examined the part and figured it out. It does have equations in it. So let's take a look. I'll edit the equations. And you can see overall length, side. Some of these things are specific to this part. Some of these dimensions have been renamed. This is instead of D2 at this, I've been renamed them to overall length, side, length at outline, spacing. So you get the point that those have been renamed, so when you see overall length in a minute here, it's not guessing at that. I renamed it to that. Import and export. So let's export these out. I get to choose which ones I want to export out here, and I can also choose to link these ones to the file. Also here in the active column in the background on the actual equations editor, you'll notice a new icon show up. Notice it's just 1, 2, 3, 4, 5 right now in the checkboxes. When I save this out, if I choose link to file, it'll now be linked to that file. When I hit save, I'm just going to call this my equations. Oops. I hit caps lock. My equations. And just to make it easy, I'm just going to throw it on the desktop here. And now that's exported, but now you notice that little icon, it looks like a little file there. That's actually, I'll hit OK. You can see where it's linked to as well. A text file called My Equations on my desktop. And let's take a look at that. And you get an idea of what it is. It's just a text file that says equals. And I'll edit this in a minute, but basically it's not. Now it's linked to this text file, an outside file that I could share, put online, put on the network or something like that, and use this over and over again in parts. So this is actually part of an assembly. Let me jump back into SOLIDWORKS here. And this is part of an assembly where there's two plates and a pin in those two holes holding it together, basically. So it's a front plate, a back plate, and two pins in there. And I should have opened that up ahead of time, but now that I've already modified it, I don't want to do that. I'll open up the back plate now. I need these two holes to match up. Now it does have, when I click, you see it does have length and height and overall length and stuff already built into it. So those dimensions are named exactly as the ones in the equations. There are no equations, as you can tell by the feature tree here. There's no equations folder yet. Tools. I'm sorry. Insert equations, right? Always forget where equations are. Do you see it? There it is. Instead of adding them now, I can import, and I put that on my desktop, right? my equations. And you see I can bring them in. I can choose which ones I want to turn on or turn off. If these don't match up, and I'll show you where they don't match up in a second, it's not going to know what to do with these equations. Notice these are really not equations so much as global variables for some of these. Overall length is a D1 equals this. So it's kind of, even though it's an equation, it's also sort of a variable. It's telling me where it's linked to. Again, I click OK, and if I rebuild this, I should see it update. So you can see that I can have this sort of list of equations now that I can reuse over and over and over again. And now let's take a look at linking these a little bit differently and what happens in an assembly level. Let me just go ahead and close this one. And I want to open up another part here. Actually, let's go back to this and let's do that if-then statement. I'm sorry, I lost track of where I was here. It's basically, I'm going to add a new equation. I'm going to say the overall length. So let me go back here. You know, the overall length is 100 millimeters on this thing. When it shrinks down to lower than a certain amount, I don't need two holes in there because they're going to be right on top of each other at some point. So what I want to do is shrink this so that when it hits a certain part, it's not linked anymore. So, or it suppresses this using that new if-then functionality. So I'll add an equation here that says overall length, which I need to be able to grab that from the equations folder here. Overall length equals let me remember my syntax. And luckily I did put this in the slide here, so you can find this in the help, but it's if whatever is a certain thing, then it's true versus false. So again, what I want to do is just say I actually mix that up. What I actually want to do is say suppress the linear pattern when it's a certain overall length, right, based off of that. So I picked the wrong parameter at first. So let me do that again. I want to say this linear pattern, linear pattern equals IIF parentheses of the overall length, if that's less than a certain amount, let's say 40, then comma, suppress that feature. So suppress the linear pattern if it's less than 40. If it's not less than 40, so if then, unsuppress it. So basically it's saying if that overall length drops below 40 millimeters, suppress the linear pattern, so we only have one hole. If it's over 40 meters, leave it unsuppressed. So I click OK, and I've had that new equation in there. I hit rebuild, you know, it's not in there. Now, the other problem is that equation, I can do this, so that's not actually exported. Notice the icon here because I added it after I did the export. So it's not linked to that text file anymore. So I'll re-export that out, make sure it's checked, save it. I can overwrite my equations, and now it's linked to it. So I overwrote the one that I had on my desktop there just for this example. Now I click OK, and when I go to my desktop and open this guy up, I can say overall length now equals 35. Save it. Remember, you have to save it for it to read it. Go back to SOLIDWORKS, hit rebuild. It reads from that equation. It suppressed this feature. It added, you know, it changed the overall length. Let's go back. You know, we can change this to 100 or back to 100. Save it. Test this out. Do our rebuild. And I should see it go back to 100 and unsuppress this feature. So kind of a real powerful tool that you can link to with these text files now. Let's look at the assembly of this now. And you can see basically the assembly is got this pin in there. So now what I want to do is do the same thing in the assembly level, but I want it to suppress the pin also when it suppresses the linear pattern. So I want an if then on the assembly level. If its overall length is shorter than a certain amount, to get rid of the second pin. We don't need that. And there's no equations in here, so we'll import our equations. Let's see, tools, where is it here? I always have so much trouble finding this thing. Tools, equations. Import from the one on my desktop there, my equations. And it says equation is invalid. Equation is invalid. Equation is invalid. And syntax. So basically you could see there were 6 equations in that, if you remember. I only had 2 of them that will actually work in this assembly. So it's just, that's what can happen if you can't bring in all the equations in there, because there's already something in this apart, or that it was specific to this feature that doesn't exist on the assembly level. You know, one of them was something at this hole, you know, at part 1, or D2 at hole 1. Hole 1 isn't in this assembly, so it can't bring that in. It can't bring that assembly in, or that equation in. So don't get scared because you get a couple errors. The other thing is you may only have, you know, you may have one for assemblies, you may have one for something else. So overall length inside, I need to add the new equation also. That so we'll add an equation, and I want to say in this case I want to suppress that second pin. So it's going to be another one of those if-then equations in there, and so it's going to be pin 2 equals IIF parentheses overall length, which is this equation right here. For some reason you can't select it here. You have to still get it from the tree, the equations folder in the tree. If overall length, same equation as we had before, is less than 40, comma suppress. If it's over 40, unsuppress it. And then make sure you close the parentheses there. And now it's got that, yeah, it's not linked to the outside one, but we can re-export that. But I just want to test this. Hit OK. Now, I don't have that dimension in there, but I have it linked to this file, so let's make this 35 again. Save it. Come back here, rebuild. And it suppressed the pin in the feature tree, as you can see here. Go back, you know, change it to 100. Oops. 100. Save it. And rebuild. And you can see now the pin is unsuppressed. So it's kind of cool. It also shows up in the equations editor of some of the things you can do there. So really powerful stuff you can do now with the if-then, and then just linking to that text file. And kind of something I thought about with that text file is global variables. So let's go back to my, where's my window menu? Was it this guy? Nope. That block I made earlier on. Probably this one, yeah. With the scale feature, I didn't put any dimensions in, so let's just add a dimension in here of 1 inch and 2 inches. So I have those dimensions. Now I can add equations to this, right? And this time I remember where it is, tools, equations. Add A equals 1.5, and let's say B equals, and this is basically what I'm doing is now I'm adding a global variable, right? B equals 2.5. And I can export this out, save it to a file, and I'm going to say, you know, global variables text file. Save that on my desktop like the rest of them. Again, you can always see the path. It's now linked to that. I click OK. And the reason I'm doing this is because I want to show you that, let's link these values to those global variable A and link this value to global variable B. And when I rebuild, obviously it changes the size a little bit here, and now those dimensions are linked in the right thing. But that's linked to the outside file. So when I go to my desktop and I look at my global variable text file, notice also in here, this is kind of interesting. If you actually just look at what the text file shows, it's just A in parentheses equals that. When we look back at my equations one, you notice overall length. So it's the name of these dimensions. So if you're, kind of clever enough, or you could really come through and actually build this stuff before you even export it and import it. I use that to get the syntax, but I really could have built that anyway. Where is my other text file? This one. So I could come in here, put parentheses, C equals 3.5, and save that. And if I import that into a part now, it'll have a C, an A, B, and C. So you can come ahead of time, define a bunch of global variables for a project or specific assembly. You're building 10 parts for this assembly, 100 parts for this assembly. You can set up all this stuff, and then all you have to do is just link to those things. So you link those dimensions to these global variables that exist in there. So, let's save this. Jump back over. Hopefully I'm making this clear enough here. Jump back over to my assembly. Get rid of all the equations. Whoops. Or, you know what? Let's just make it even easier on myself. Let's create a new part. And insert equations. Import them from the desktop. So now I have these global variables that I can import, and I get A, B, C, and D already in my parts, or I have overall length already in my parts. And then when I come in here and I'm just designing and I'm building a part and I put a dimension on it, I get that option right here that I can link to that. And they're all on the list there. So if you're not using this kind of functionality, it could save you quite a bit of time. This is actually a really good technique if any of you have ever taken the CSWP to go ahead and set up some global variables, because they basically randomize the dimensions by A, B, C, and D. If you set up those ahead of time in your templates or your parts, you save yourself a few minutes and you just link to those dimensions and then edit those. Because question 2 now changes A, B, C, and D. So little CSWP tip for you on taking the test to save off a minute or two of time, in the long run. All right, that's equations, and global variables are some of the enhancements to global variables. When I jump back over to my slideshow, the other enhancement is the global variables are configurable. So I won't go through and just configure that stuff, but you can now do it in a design table. You can see the value in there, and you can always get this stuff from the help menu, the syntax. And there's usually an example, so it shows you, part 1 instead of just global variable name. In our case, it was $VARA, So those are all that stuff. You can figure out what that is through the help menu as well. But I kind of put some of that in here in this slide. So global variables can be, design table specific as well. And it takes us to our last topic here, surfaces. Let's jump over into SOLIDWORKS and take a look at those again. And while I'm here, let me just make sure I'm not missing anything. Good. And I have a few sample parts. Surface is actually cool. What happened when I was learning about surfaces is there was something I learned that that is a what's new that I can't find really any documentation on. So I'll show you that after I show you the surface stuff. But basically it's the ability to extrude anything now as a surface. And that's a 3D or a 2D face can now be extruded without having to do a sketch. So in previous versions you actually had to draw some type of sketch or get an edge or something to extrude as a surface extrude. If you hit extrude now, you'll see there's a section here now at the bottom. So what you would see is this first section here, kind of, but now it says to extrude from a face, do one of the following. Select a 3D face or press Alt and a 2D face. So let's just take this 3D face here. And we have to give it a direction, so I'll pick this face as the direction. And you can see I can extrude this face. Remember, it's a surface extrude, so basically it's taking the edges of that face and extruding it up. Go back and edit that thing and take a look at some more options, and that's the second bullet that was on my slide there. I can pick more than one face to extrude, and I love that you can pick the same face as the direction you picked. That used to be always a pain in the butt. There's another option here to delete original faces and cap ends. So when you extrude a face and a surface, I could cap it. Notice it's capping that end there. Hopefully you can see the difference in the preview. I'll do it just in there like that. Edit feature. Choose to cap ends, and it's capping it. Remember, this is a surface on top of this part here, right? So the part itself isn't, let's just pick some kind of material so you can see a little bit brighter there. But this is just a surface. This is hollow, infinitely thin right there. What I can do is edit this, and I could say delete the original faces, but let's do it a different way. Let's go ahead and take these fillets along with it. And this would be a good tool if we're importing parts and we don't have a feature we can edit just to change this, a sketch. You can use a lot of surfacing tools and moving faces and stuff. Move face would probably accomplish this even better, but delete original face and then knit up the results to turn it into a solid. So I can hit that, and now I basically extruded that on top of it using that. That's one way to use a new tool, having that cap ends. The other, I can hit extruded, and instead of selecting a 2D face, if I just select this face, notice it's going to put me in a sketch and want me to draw a sketch on there. If I do that extrude surface again, hold down the Alt key on my keyboard and select this face, then it allows me to extrude that face. Again, I can cap ends if I want to as well. So then it allows me to do that surface extrude in there without actually having to start a sketch and convert those entities and then extrude it. Now, I said there was a little thing in there, the thin feature tool. That's not extruded surface, as that's basically extruding a solid or a boss or base. Kind of a neat thing that I stumbled on when I was just kind of preparing for this webcast and learning the what's new stuff is on a fresh part, and I'm not sure. I guess I'm going to have to troubleshoot this a little further. Why it works on some parts and not. I'm assuming it's just because there are no ends on the part yet. So when I extrude this and I choose thin feature, I get cap ends. But if I extrude when there's already a solid, I don't get cap ends. I'm not sure if this is a bug or a mistake, but it's kind of a cool feature. I can make a shelled out part without making this and then shelling it out, and not picking any faces when you do shell. We'll remove all the material inside. So if I section view this thing, you can see it's a capped end but hollowed out part. So again, I figured it would have worked on anything, but it looks like it only works when it's the our initial feature and nothing else is in there. So kind of something I stumbled across that's not really documented, that cap ends in the thin feature option, but does seem like, hey, it's new. Whether they change it and fix it in a service pack, it's new, it's in there. So anyway, that's the last topic here, surfacing. That's what's new stuff. Remember, we have a bunch of what's new webcasts coming up to cover more topics. I think our next one is the mold design, sheet metal. These will be archived. If you have any questions, feel free to type them in. Otherwise, I'm going to go ahead and end this webcast. I'll give you a few minutes. If I don't get to your questions and you still have some, feel free to contact our support department, and we'll answer those as soon as we can. Thank you all for coming. Hopefully you learned something.